Okay, so we're talking about divisibility rules, okay? And when you say that something's divisible by something else, that means that it will divide into there evenly with no remainder. So, a number that's divisible by 2, we said, is even, or it ends in 0, 2, 4, 6, or 8, okay? So a number is divisible by 2 if it even basically ends in 0, 2, 4, 6, or 8. Does anybody know the divisibility rule for 3? You add all the digits together, okay? And if the sum is divisible by 3, then the entire number is divisible by 3, okay? So, you add the digits, and if the sum is divisible by 3, then the number is. So, if you had something like 252, okay? 252, if you add the digits up, you get 2 plus 5 plus 2, which is 9. 9 is divisible by 3, so 252 is divisible by 3, okay? All right. What about the rule for 4? This one you may not remember. Oh, very good. If the number formed by the last 2 digits is divisible by 4, then the entire number is divisible by 4, okay? If the number formed is by the last 2 digits formed so like 3/24, okay? If you look at 3/24, the number formed by the last 2 digits is 24. So if you can divide 4 into 24, then you can divide 4 into 3/24. The only exception to that is if it ends in a double zero, okay? And that's always divisible by 4, okay? Okay, you can always use this rule if you want to determine if it's an election year. Yes? 2020, is it election year? The last 2 digits is a 20, right? The next election year would be 2024, and then 2028, so forth, right? You can always know if it's an election year. Okay, what's the rule for 5? Ends in a 0 or a 5. Okay, what about 6? Okay, it has to be divisible by 2 and 3. Okay, so must be divisible by 2 and 3. Okay, how about 9? True, but not everything that's divisible by 3 is divisible by 9. Like, not 3 is not divisible by 3, right? The rule is similar. So it's the sum of the digits. If the sum of the digits is divisible by 9, then the number is. So again, we could use the number 252, because when you add those together, you get 9, and 9 goes into 9, right? But like we could use something like 111, right? 111 is divisible by 3, but is it divisible by 9? No. Okay, so to be divisible by 3, you add the digits up, and it has to be divisible by 3. The sum does. Okay, for 9, the sum has to be divisible by 9. Okay, what about 10? Everybody should know this one. Ends in a 0. Okay. All right, so far we've learned these, but the ones I really want you to focus on so far are these two, okay? Now, this next one, I want you to focus on it too, and I want you to think money. Okay, think quarters. How do you know if something's divisible by 25? Or let's say you could go and pay in all quarters. How do you know if you can go pay for something in all quarters? Ends in 25, 50, 75, or 00, right? Okay. Okay. This one's really important. How do you know if something's divisible by 100? Ends in double zero. Okay. And all of them are important, but these specifically are because these are perfect squares. Okay, and we're going to talk about what that means here in just a moment. Okay, so let's look at these numbers right here. Okay, what will divide into these? Okay, 25 would. Okay, 5 would. That's probably it, right? Okay. What about this one? 2. 4. And it ends in a 24. Probably it, huh? That I can think of. Okay. What about this one? 100. 2, 10. 25. 5. And 4. Right? Okay. What about this one? 5. 3. Not 2. It ends in a 5. 9. Okay. What about this one? 3 and 9. Okay. What about that one? 25, 10, 5, 2. Okay. All right. So these are important that you begin to recognize what's divisible by something else. And again, these perfect squares are really going to be helpful if you can recognize those. Okay. All right. Now, we're going to start talking about how to simplify radicals. This little symbol right here is a radical sign. The number that's underneath it is called a radicand. Okay? And if you plug radical 18 into your calculator, you get some big long number. Okay? You get 4.24640,687. But you know what? This number really actually continues on. The calculator has rounded this number at this point, okay? Because this number is what's considered an irrational number. When you take the square root of something, you're looking for what number that multiplies by itself to give you that radicand. There is not a single number, whole number, that multiplies together to give me 18, yes? Is there a number that multiplies together to give me 25? 5. So the square root of 25 is 5. That's considered a perfect square, this 25 is, because I can actually take the square root of it and get a whole number, okay? That's called the principal square root of the number, the positive one. It actually has 2 roots. It has a positive root and a negative root, because negative 5 times negative 5 gives me 25 also, yes? Okay? But we are just going to be interested right now in the principal square root, the positive square root, okay? Okay. And so what I've done here is I've listed several of your perfect squares. I'm going to talk about a couple of other ones here in just a moment. But this right here is considered an approximation. Even though it fills up the calculator, it still is not an exact answer. This is an exact answer, and we're going to talk about the difference between the two. Okay, so what's the square root of 4? 2. What's the square root of 100? 10. What about the square root of 25? 5. What about the square root of 225? Huh? 15. Okay. Square root of 81? 9. Square root of 36? Square root of 49? Square root of 144? Square root of 9? Square root of 1? Square root of 64? 8. Square root of 121? Square root of 169? 13. Okay. Square root of 16? 4. Square root of 196? 14, and the square root of 400. Okay? All right, you need to know these, okay? You should know them like the back of your hand, all right? When you see the number 169, you should think, oh, the square root of 169 is 13, okay? Now, how do I remember that one? Well, this road right out here, 169, is unlucky for lots of people. Yes, lots of wrecks on 169, right? There are different times during the day. 13 is an unlucky number, so the square root of 169 is 13, okay? If you transpose those last two numbers, you get 196. That's 14, okay? Square root of 196 is 14. So those are sometimes hard for people to remember. Square root of 256. Anybody know that one? That one's 16. That's another good one to know. Okay, now, radical 18, it falls right here. Yes? Radical 18 falls right there, in between, right? So when I plugged it into the calculator, I got 4.2 something, correct? Okay, and notice that radical 18 falls between these two perfect squares. So it makes sense that it's 4 point something, yes? Okay, and that's another good thing to know also is kind of how to approximate a little bit. For example, let's say I wanted the square root of 72, okay? It's going to be approximately what? 8 point something, right? You know it's going to be approximately 8.5, something like that, right? Okay, that's important if I'm wanting to estimate how, long a board is or something like that, and I'm having to use the Pythagorean theorem, okay? That would be important to know that it's about 8 point something, okay? But what we are going to do is instead of getting approximations, we're going to get exact answers, okay? This is not exact. This is an approximation, okay? This is exact because it's a perfect square. Okay, so let's look at the other paper for a minute. Okay, so all right, we got some radicals here, and this paper calls them surds. Okay, like the radical 5, they call it a surd. Okay, radical 2, radical 17. They don't have a perfect square. Okay, they're not a perfect square. Like there is not a number that multiplies by itself to give you 5, right? Okay. These are called irrational numbers because they go on and on and on and on and on irrationally. Okay, there's no pattern to it. Okay, there's no termination of it. They're called irrational. What we can do sometimes is simplify them and keep them exact. Like this is considered an exact answer, radical 5. Can't do anything to simplify it. Sometimes I can take my radicand and I can break it into two factors, one of which is a perfect square. And so that allows me to simplify it, okay? So if I take the square root of a number, break it into a times b, then I can rewrite it as the square root of a times the square root of b, okay? And if one of those are a perfect square, I can take the square root of it and I get a different answer, okay? I get an exact answer. For example, look at this problem right here. The square root of 18, okay? The square root of 18. 18 can be broken up in a lot of ways, right? 1 and 18, 3 and 6, or 9 and 2, okay? Now, 9 and 2 is special. Why? Because the 9's a perfect square. I can take the square root of 9. I can't take the square root of 6. I can't take the square root of 3. Can't take the square root of anything else. But if I break 18 into radical 9 times radical 2, radical 9 is a perfect square. And I can take the square root of it, which is 3 times the square root of 2, and then I can write it as 3 radical 2, okay? So, let's take radical 32, okay? You can use your divisibility rules on these because we're looking for those perfect squares. You know those ones I circled? Those are important. What goes into 32? And I want one of the what's to be a perfect square. Okay, 8 and 4, all right? So I can break this into the square root of 4 times the square root of 8. I can take the square root of 4. What's the square root of 4? 2. Now, if I look at 8, Luke, is 8 a surd? Is it simplified as far as it can go? Does it have a perfect square in it? It doesn't? What? 4's in it, right? Okay, so honestly, this one could be broken down, 8 can be broken down again into radical 4 times radical 2. Now, I can't throw this first 2 away. It's like we're taking numbers and we're breaking them down into all their factors. If you took 6 and broke it into 2 and 3 and you got rid of 2, it's no longer 6, right? So you got to hang on to all of these factors. Okay, so we keep this 2, and what's the square root of 4? 2. So now we have 2 times 2 times the square root of 2, and this 2 times 2 is 4 radical 2. Now, in hindsight, could I have broken 32 down differently? 16 and 2, right? And you'll start recognizing this because I could have broken it down into 16 times 2, and the square root of 16 is 4 radical 2. And I've gotten the answer with a few less steps, right? Okay? And so now I've broken it into where I have a surd left under there that can't be broken down, okay? And I know I'm done when it's a surd, when it doesn't have any more perfect squares in there, okay? All right. So let's do some examples here. Back to the other paper. Okay, we already did radical 18, right? Okay, what about radical 24? Okay, this breaks into the square root of 4 times the square root of 6. 4 is a perfect square. What's the square root of 4? 2. So I end up with 2 radical 6. Another thing with checking to see if it's divisible by 4, if you can look at it and mentally divide it by 2 and you know you're going to get an even number, you know you're going to be able to divide it by 2 again. Okay? So that tells you, okay, this is divisible by 4. That's another thing that you can use with 4. Okay, we already did 32. What about the square root of 50? Say money. 25 and 2. Okay, so the square root of 25 times the square root of 2. What's the square root of 25? 5 radical 2. Okay, now this one has a coefficient in front of the radical. Still works the same way. This just means these two things are multiplied together. So I still go and look at my radical and I say, okay, can this be broken down? Can 12 be broken down? Yes, into 4 and 3, right? But I have to hang on to that 3 in front, and then this breaks into radical 4 times radical 3. And I can take the square root of 4, which is what? 2, and I multiply it by the 3 that's already in front, so I get 6 radical 3. Now, the main thing you got to remember is that when you break it down into the two factors, you want one of those factors to be a perfect square, okay? It's going to make your life easier, okay? All right, now what about this one? What do you notice about this radical? It is a perfect square, right? When you take the square root of something, that radical's gone, right? So the square root of 16 is 4 times the negative 2 that's already there, so my answer is negative 8. Okay? What about this guy? We've got a 7 radical 40. What am I going to do with 40? 4 and 10. So I'm going to break this into the square root of 4 times the square root of 10. The square root of 4 is 2 times the 7 that's already there. And so I end up with 14 radical 10. All of these answers are exact. If it asks for an exact answer, that means no rounding occurs. Okay? You will not be allowed to use your calculator on the assignment today, or the assignment tomorrow, or the assignment on Friday, or the quiz that we have over this information. These calculators are magical. They do everything for you. Why would I even teach you how to do this? Because you need to know how to do it for your upper level math. Okay? It's important. It's critical. Okay? You may not see the reason now, but it is very important. Okay, now in this problem, we're going to work backwards. Okay? Because here, we took this and broke it apart. This one's broken apart. You think I can put it back together? Yes. If you multiply two radicals together, your answer stays under the radical. Okay? So what do you think radical 3 times radical 15 is going to be? Radical 45. Okay? But then, I need to see if I can simplify radical 45. Can it be broken down to where it has a perfect square factor? Yes. 9 and 5. So this breaks into 9 times 5, and the square root of 9 is 3 radical 5. Okay, what about this guy? Radical 7 times radical 7. What do you think that's going to be? Radical 49, because you multiply, okay? But radical 49 is 7, isn't it? So what conjecture could you make when you multiply two radicals that are the same together? basically the radicals cancel each other out, right? Okay, that's always going to happen. If I did radical 3 times radical 3, that's going to be 3. Okay, because this is always going to end up being a perfect square, and you're going to take the square root of it and get that number. Okay. All right, what does it mean to square something? Multiply by itself, right? So in this problem, I have 3 radical 3 times 3 radical 3. Okay? 3 times 3 is 9, because you multiply those coefficients together, because they're outside the radical. Then you multiply what's inside the radical together. What's radical 3 times radical 3? 3. It's radical 9, right? But remember we said when you multiply a radical by itself, you end up with that number minus the radical. Okay? You could go ahead and show that step if you wanted to. But radical 9 is 3. And then you multiply those together and you get 27. Isn't this fun? This is fun stuff right here, guys. All right, let's do one more. Okay? What do you think we get here? Remember, you multiply what's outside together, what's inside together. Okay, I end up with 12 radical 20. But can this be simplified? Yes. Well, how am I going to break 20 down? Okay, radical 4 times radical 5. I always put the perfect square first because I know that it's going to come outside of the radical. Not, you don't have to do that, but just to me that makes more sense. The square root of 4 is 2 times the 12 that's already out there. So we end up with what? 24 radical 5. All right, so no calculator. You need to memorize these perfect squares. Okay? You need to memorize. What's the square root of 4? 2. What's the square root of 9? 3. Dan, what's the square root of 64? 8. What's the square root of 100? 10. What's the square root of 81? 9. Maya, what's the square root of 25? That times itself gives you 25. 5. Good, good. What is radical 3 squared? Radical 3 times radical 3. It's 3, right? Okay, good. So you guys need to know those. You need to know them really, really well. It's going to make you a better math student. Okay? All right, I won't pick on anybody else. Any questions? Okay? I better not see any calculators, and I'm going to do that tomorrow. Better not see any calculators. Show me the work. It's minimal, but I still want to see it. Okay? All right? Okay.